It's going to be a video going over my code, just so I can kind of cement it more in my mind and explain what I've done. So yeah, this is the script, which is kind of the backbone of the entire project. It's fetching the transactions from Etherscan, and yeah, one's over 100,000. So obviously I've got my imports needed at the top, the things I needed for the script. I've got my Etherscan API key there, just so it's easy to reference. And in future, if that changes, then I can just change that instead of digging through the code. I've got all the addresses here, the ones that I'm going to be tracking. That's going to change in the future. I've just kind of got a few here that I'm kind of experimenting with. I've got my database URL there, it's my neon.tech database. This is the one here that's storing all of my data that's shown on the website, and the ones that's being collected from here. So I've got my insert function, my store transactions function. So yeah, this is going to organize the data from the API, so it's easy to reference throughout the code, which is obviously essential. Obviously got the database underscore URL being referenced there. That's going to be the Neon Tech key to connect that. This is going to establish a connection to that database. Insert query, insert into transactions, which is the table from the Neon Tech database. This is called transactions. And then yeah, that's going to do an insert query, which is essentially going to insert that into the database. It's not going to remove any data, just insert. And that's going to organize that from the hash, the from address, to address, value USD, timestamp, and block number. That's all the data that I'm going to collect at the minute. In the future, I may start to move on to like get gas fees or blockchain times, like how long it took to send, stuff like that. Yeah, connection commit's obviously saving that into the database as the code runs, and then connection closing that connection, and then that's essentially stored the transaction then, so printing that out. Getting the Ethereum price is essential for this, because obviously we want to like a USD value with the trade, so figuring out how much has been sold that's more tangible when just looking at it, because you obviously don't want to convert ETH all the time, and then referencing that over time gets tricky. So got the API CoinGecko, which I can use for that to collect that in real time. That is essentially going to response raise for status, which is going to make an online connection, and obviously we're getting the Ethereum value and the USD value, and then if that doesn't work, we're going to do error fetch and price, which helps for troubleshooting, which hasn't happened yet. Get latest block, that's going to, this was something that I changed later on in the code, because the code was running and finding transactions from over a year ago, which isn't ideal. We need ones that are only 24 hours old. So yeah, I've done that. That's going to do the latest block, and that's going to do the last 10,000 blocks, I believe. Oh yeah, there it is. Yeah, so that's going to day and a half depending on volume. But yeah, that's all we need. And yeah, that's that. This is the main monitoring logic, so the transactions that we're actually going to store, because obviously it's going through the data, so it's obviously got to sift through it. There's knowing what we want in our database and whatnot. I changed this over time. At first, I was only storing transactions over 1 million, but it just kind of didn't give me enough data to really do stuff with. So I've reduced that down to 100,000. And yeah, that's going to check the addresses that we've referenced up here. It's then going to multiply the ETH price that we've got from the get ETH price part of the code, and yeah, it's going to times that to get a yeah, dollar value, and we're finding ones over 100,000, storing that in the right code to make sure nothing gets mixed up over the way, because that's something I had trouble with at the time. Some code was trying to store it as an integer and it needed to be a text, a string. And yeah, that is that code. In terms of the SQL that I've written, very simple. It's just a create table transaction script. ID serial, so we've got a serial number for every single value. So that's just a reference on our end. They won't need that. You've obviously got the hash, which essentially is the kind of unique identifier for the transaction, so we don't really need that. It's just more for a primary key for this. And then yeah, we've got them saved as strings now, because that's all we need. We obviously need letters and numbers for that. Value USD is numeric. Timestamp has to be done this way, otherwise it can get tricky. Block numbers integer, not going to need a float for that. And obviously gas used and gas price, this will be due to change in the future, but I'm not using it right now. And yeah, that's it. And these were just ones that I used for the start, so ignore that. And yeah, that is, obviously don't really need to walk through this. I'll walk through my HTML. So yeah, that's just to get the modern looking table. I've done a tiny bit of making it look clean, but it's obviously a very simple website. But I just imported that style sheet just so it's easier to just make it look a bit nicer instead of like just blocks. Obviously got that going on. Got the Ethereum blue color. Yeah, very simple stuff. We've got the bootstrap there. And yeah, that is it. And then the rest of the files in the GitHub, a lot of these are just prerequisite stuff that I'll need. So yeah, that's that. This connects the HTML document, I believe. Yeah, so this is for the render stuff. This is essentially just so I can connect the HTML document to this host and service that I've got, and at the same time be able to have a free flow of data going on. And yeah, I think that is it for this video. Thank you for watching.